Hi there. This video we will talk about how to use the Excel templates. This is for assignment 3. Some student asked me about how to use the templates. So this video we cover 3 templates. We will talk about proportional test, one sample that test, two examples on one sample that test. So first, let's look at a proportion test. So this is one proportion test. We use the example from our notes. Remember, we have a notes on slides, chapter 15, slides 22. Suppose we have 800 students chosen at random from a student body of 20,000 to get a flu shot. And among these 800 students with exposed to the flu, and 600 of them did not get the flu. So so that's basically a question asked what's the sample size. In this case it's 800, and the point estimation, we know 600 out of this 800 did not get the flu and then the question asked for 99% confidence interval. So that's basically, this is from the notes. We already have the result. So this video we just go quickly through, so I don't cover each questions. And then goes to we want to do the Excel calculation of the confidence interval. And this one, there's 2 methods. One is we use the templates. We'll talk about this later. And then another method is we do the calculation by yourself. So there is, we know the n value 800, success is 600, p-value just over 600 divided by 800, we get 0.75. Standard deviation, so let's remember we use the p and the q and then divide by n and square root, get this standard deviation. And alpha level, since we want calculate a 99% confidence interval, so we set alpha level 0.01. And there's a margin of error. Remember, margin of error is basically this portion. Excel has a function to calculate this value. It's called, we just use a norm standard invert. That's the 0.01 is our alpha level. So 99% confidence interval, remember it's two-sided, so let's use norm standard inverse and use this 0.01 divided by 2, that's 2 sides, and then multiply by, remember we calculate this standard error, right? So multiply by this value. So that's give us the value, so basically this portion, and the norm inverse is this portion, and then multiply by this standard deviation. I'll get the margin of error. Basically, this portion is calculated here. And this one I use absolute value because of the Excel calculator on the left hand side, and we want the value is only 95% on the upper side. So this value, once we get this value, we use the mean value, subtract this one, and the mean value, that's 0.75, plus this margin of error, get this value. Let's look at the proportion test templates. Wait a second. I just drag this one on the other screen. We need so there's some values we need to insert. So that's templates. So this templates covers 1 proportion test and 2 proportion test. Later on we will use 2 proportion, but right now for assignment 3 we only use 1 proportion test. So in this templates, basically this is the format of our old templates. The blue cells indicate that the input value which require you to insert those value, and the red cells is the output value. So you don't have the control over those red cells, but only require you insert the input value. So remember the discussion I said, do not delete those red cells, because red cells has the equations associated with the this cell. So now we look at this proportion test. Remember, we have sample size is 800 and success count is the 600. And this one, because we don't know the population proportion, but sometimes in this case we only need the confidence interval, not really need this z-test value, so they didn't give us the population proportion. We can use this value we can use the sample proportion to replace this one, 0.75. And then there's a hypothesis test. In this case, we don't have a hypothesis test, but we need the alpha level to get a correct answer. So this one is we want a 99% confidence interval. So the alpha level 0.01. And what happens now, you see the result, confidence interval, 99% confidence interval directly give us this value, 0.7105, 0.789, which agrees with our, let's take a look back to our assignments, our calculation. This is a hand calculation, 0.71 and 0.79. That's agreeing with this one. So for the assignment, I require you copy and paste your templates result over your assignments. So you can use snipping tools and copy paste. In this case, because we don't have that value requires, you can just copy paste this portion and then paste it over here. Okay, so let's give us your templates output. That's for the proportion type of question. There is some confusion because we study the this chapter. We cover one is a proportion test, one is a sample mean test. Sample mean value, that's the second example on chapter 15, slide 43. So this question is basically is a IQ test score. It is known that the score on the Stanford Binet IQ test is normally distributed with standard deviation sigma equal to 16. Suppose 20 people are randomly selected, and then their mean IQ is we should use a Y bar here, equal to 94.56. Calculate a 95% confidence interval on the true population mean IQ score. And this is the calculation. Let's use the hand calculation. We have 87.55 and 101.57. Same thing as before, we can calculate, because this one has the mean value and standard deviation, we can calculate, there is a margin of error calculation. So that's basically is z alpha over 2 times sigma over square root of n. So this portion is our margin of error. This function gave us, so in Excel there's a confidence norm. We have alpha value 0.05, and then this is the sigma value, and then is nth value. Select these three. With this function give us the margin of error. We calculate a lower bound is use our mean minus margin of error. That's the mean minus margin of error. This is mean plus margin of error. So these two values agree with this one. And let's take a look of the one sample z-test. You probably notice there is two one sample z-tests. One is called so that test template summary data, and one is called with data. So this one is basically we do not have the data, but rather the summary values. And this example is basically give us the summary values. We don't have the 20 people's score to calculate. So anyway, so let's take a look at this one sample z-test templates with the summary data. Similar with the previous one, we have the blue cells, which requires you fill in those values, and then the output will be coming out. So with this one, we know the sample size of this one is 20. Sample mean is 94.56. And the population mean, same as in the previous proportion test, so we don't have the population mean. Sometimes it asks you to test the sample mean with the population mean, so it will give both value, but in this case we don't calculate that test value, but rather the confidence interval. So that's 94.56. Just put down here, and we know the population standard deviation is 16. And then this alpha level, we want to calculate 95% confidence interval, so 0.05. So we get this value. I just use the I just copy paste this value to this figure into my assignment, or in this case is my examples here. So I just paste here. So you can see we get the value 87.547. That's basically same values here. That's more accurate than our calculated value. This is for the summary data one sample z-test. Remember we talked about the proportion and the sample mean test this chapter. Make sure once you use when to use the proportion test, when to use the mean value one sample z-test. So that's basically the mean IQ test score could be any value. So the mean, it represented the mean value. Proportion is basically it's just there's a success case and a fail case, and then the proportion like 50% people passed, or 20% of the home runs, that things like those is a proportion test, and this is a sample mean test. Let's look at the one sample z-test with the data. This is the chapter 17. We have the last couple pages. We have an example on the canned shrimp. So that's basically, I don't cover all those values here, but we remember we have a salinity solution values, data values here. Just use, I need to copy those data. So there's total of 57 data here. So Control C, and then we go to the one sample z-test with data, and I need to paste my data here. Okay, so once I paste the data here, you can see some values already shown, and then same we need to write down, just put this news over here. So we need to fill in the some values here. So the population mean, our test with the population mean is 2.5. The sample mean here is 2.6. We just want to see if this one and this one agree with each other. And also population standard deviation is 0.43, which is given in the question. The question test is there any difference? So our hypothesis test is equal, and then this one is not equal, because we want to see if there is any differences. And then alpha level, since alpha level given 0.05. Okay, so once you see, once we fill in these values, we immediately get our test results. So that test value here is 1.817. I don't have much time left. And then because this is not equal, we have two-tailed p-value. So I just copy this figure to the assignment, the examples. And so just explain a little bit here. Just put down here. Although some values does not require, but we still talk about this one. And remember, we have. So the hand calculation, the test statistic is 1.82, which is agreed with our that test value 1.817, approximately 1.82. And this, we already talked about, this is a two-side hypothesis test. So we rate the p-value two-tailed, which is 0.06915. A little bit accurate than this value because this 1.82 is an approximation, but this value is calculated using this value. And then the 95% confidence interval 2.49, so that's agreeing with this one, and higher bound 2.7151 is agreeing with this value. So that's basically that's give us the result from the templates. And I probably run out of time, so that's all for this video today. We covered 3 templates. Thank you. Bye.